Hey everyone, here we are for another lesson in on our geometry, continuing our unit about measurement of figures, focusing on volume. So we'll go through the different figures, give you the formula, apply it in a couple practice problems, and go from there. So when we talk about rectangular prisms and cubes, our formula that we'll use to find the volume is length times width times height. You see all of those spelled out there. For a cube specifically, it's going to be the side length cubed. All right, so for this first problem, if we were to find the volume of this rectangular prism, you would just multiply 9 times 9 times 13.5 and get 1,093 and 5/10. And since this is volume, it's in cubics, so this is cubic meters. All right, same thing with this next one. 8 times 17 times 12. The order doesn't matter because multiplication is commutative. 1,632 cubic inches. All right, next one. All other prisms, the volume is just going to be the area of the base times height. So this is illustrated for you here. Big B is area of the base, and height is the distance between the bases. So even if this base isn't at the bottom, we just know that this is the base because it's not a rectangle. So that's what makes it the base. So looking at this first one, knowing that we'll be using volume equals base times height. So that base we'll use first. The base is a triangle. We don't have the measurements for it there, but that's going to be congruent to the triangle up here. So that'll be 1/2 times 9 times 12. And then the height between the bases will be 16. So this represents big B, and then the height between the bases. So we'll just multiply that all together, and that gives us 864 cubic meters. All right, and then here we're given the area of this pentagonal base. So that's already 84.3, and multiply that by the height. This is the height, the 4 feet. And then this is a regular pentagon. That's that marking there. So that's the side length. So we don't need that. That's extraneous right now. So we do 84.3 times 4, 337 and 2/10 cubic feet. Not too bad. Moving on to cylinders, the formula that we're going to use. Pi r squared, so that's the area of the base. So it's really similar. It's all kind of like the area of the base times, again, the height. Okay, so this first one's a little bit more straightforward. So we have pi times the radius squared times the height. We're only squaring the radius. So only the radius gets squared. So you can use pi or 3.14. I'll use pi. So for that, if we round to the nearest 10, we get 15,268 and 1/10 cubic inches. All right, and then for this one, it's a little bit different. We have the height. We don't have the radius yet, but we can find that if we can get the diameter from the Pythagorean theorem. So I'll do that first. A squared plus b squared equals c squared. So 9.5 squared plus b squared equals 19.3 squared. So I'll do 19.3 squared minus 9.5 squared. Take the square root of that. That tells me that b equals 16.8. So that means the whole thing across is 16.8. But I want the radius, so the radius will be half of that, 8.4. So I'll use that to help me solve this problem now. So the volume is pi times the radius squared times the height between the bases. So pi times 8.4 squared times 9.5, and that gives us 2,105 and 9/10 cubic meters. Okay. Sorry, got distracted. Next one, pyramids. Pyramids. So pyramids go to the point up here, any type of base, but come to that apex. So the volume for a pyramid is going to be 1/3 of the area of the base times height. So again, that's what we see here, this area of the base. So 2 practice problems with pyramids now. So 1/3 base times height. So that'll be 1/3 the base. This is a triangle. So that's 1/2 times 12 times 7.5. That's the height of the base there. Times, again, the height of the actual figure, 10. So I'll clean that up a little bit or mess it up. So why though? Why? Is this a joke? Is this a joke? Sorry. What a boomer. Half of 12 times 7.5 was 45. So we have 1/3 of 45 times 10. So that's 15 times 10. So that's 150 cubic millimeters. And then this next one I wrote over. So this is a square pyramid. So that'll be 1/3 area of the base times the height. So that's 1/3 area of the base will be 14 squared times the height, which we can find from, you guessed it, the Pythagorean theorem. So here's our right triangle. So here, this is 7 feet. That's 25 feet. We need to find that. We know that's a Pythagorean triple. So I have a squared plus 7 squared equals 25 squared. Again, the 7 came from being half of the 14. So if I do 25 squared minus 7 squared, take the square root of that, that gives me 24. So that's the height. So I multiply that all out, and that gives me 1,568 cubic feet. Cone also goes to an apex, also very helpful. Because of the apex, again, we're going to use that 1/3. So our volume for a cone is going to be similar to a cylinder, but now it's just 1/3 of that. So it's 1/3 pi r squared h. So let's try it with this first one. So we have 1/3 pi r h. So 9 squared times 17. Plug that all in. And you get about 1442.0 because it's 0.99. So if I'm rounding to the tenths, that'll leave me there. All right, and for this next one, we need our radius. So our radius will be 13.5. And then we don't have our height yet, but we can, yes, use the Pythagorean theorem. So 13.5 squared plus b squared equals 22.5 squared. So that gives me 18 as the height. So volume is 1/3 pi r squared h. So that's 1/3 pi times 13.5 squared times 18. So I'll do all that. Really loud train. Thank you, New Jersey Transit. 3,435 and 3/10 cubic kilometers. And then finally, we'll end with composite figures. Some people. So this is where either you combine or subtract multiple solids. So looking at this first one, find the total volume. They're only doing 3 of these. So find the total volume of the composite figure. So we have, this is kind of where it splits off. So we have our triangular prism on the top. And then we have our rectangular prism at the bottom. So our rectangular prism looks like that's going to be the easiest. So the volume of the rectangular prism is just going to be 12 times 15 times 9. So that'll be 1620 cubic feet. And then for the triangular prism, our height between the bases will be 15. And then we know the height here, the height of our base is going to be, if that's 12, the whole thing is 19.8. That'll be 7.8 feet. So the volume of the triangular prism is going to be the area of the base. So that's 1/2 times 9 is this base, times 7.8, which is the height of the base, times 15, which is the height of the figure. Calculate that all out, and that's 526 and 5/10 cubic feet. Now, because these are combining, I'm going to add those together. So the total volume is going to be 2,146 and 5/10 cubic feet. Did I skip spheres? Did I miss something? Yeah, I did. Okay, go back with me if you don't mind. Oh, shoosh. Spheres. Duh. 4/3 pi r cubed. This one's pretty self-explanatory. 4/3 pi, that's our radius, r, which is 7 cubed. 4 divided by 3 times pi times 7 to the third power. Round that to the nearest tenth, 1,436 and 8/10 cubic inches. So a hemisphere is going to be half of a sphere, that's the hemi. So instead, half of 4/3 is going to be 2/3. So first we need the radius here. So that's just going to be half of that, 6.1. So the volume in this sphere is astronomical. 2/3 pi times the radius, 6.1 cubed. And I got 475 and 4/10 cubic centimeters. Moving right along to what I was supposed to do before. What? Okay. Anyway, so find the total volume. So we have a cone and a hemisphere. So we can do the hemisphere first with a radius of 4.5. So the volume of the hemisphere will be 2/3 pi r cubed. So that's 2/3 pi 4.5 cubed. Throw it in the old calc. Gives us 190 and 9/10. I should round to hundredths, intermediate rounding. 85 hundredths cubic meters. And then we're going to need the volume of our cone. So that's 1/3 pi r squared h. But we don't have the height yet. We only have the slant height. So we're going to have to use Pythagorean theorem. Here we go. So a squared plus 4.5 squared equals 13 squared. Doing it on the calc. So 8 is about 12.2. Cool. So back to the volume of the cone. That's 1/3 pi. Radius is 4.5 still, it's squared, times 12.2. Do that all. Gives us 258.71. So then the total volume, I'm just combining those. 258.71 plus 190.85, 449.56. Wow, I'm being very annoying. I will stop. Maybe. Okay, and then the last one, find the total volume. Now we're going to have to subtract because we have a cube with a cone hollowed out of it. So we have to find the volume of the cube first. So that'll be the side cubed The side length is 4. 4 cubed is 64. 64 cubic centimeters. And now we have to find the volume of the cone. So that's 1/3 pi r squared h. So the radius is going to be 2. The height is going to be 4 centimeters. So that's 1/3 pi times 2 squared times 4. 2 squared is 4, 16 divided by 3 times pi, 16.755. So our volume is going to be the cube minus the cone, which will be 47.245 cubic centimeters. And that is it for volume of solid figures. Do your work. Reach out if you have any questions. Do your best. We're almost there. It's almost June. Take care. Bye.